Hey everyone, and welcome. Today, we're going to dive into one of the most transformative technologies of our time, artificial intelligence. We're going to trace this whole thing from its roots, starting with one simple, ambitious question, and following it all the way to the incredibly complex systems we see all around us today.
And this is it. This is the question that started the whole shebang. What does it actually take to make a machine think? Seriously, this single, profound query is the spark that ignited the entire field of AI. It's the challenge that researchers have been tackling for decades. So let's jump in, right at the very beginning. All right, let's set the scene. It's 1956. There's this incredible wave of optimism in the air, a real, genuine belief that creating truly intelligent machines was just around the corner. This whole era kicks off at a summer workshop at Dartmouth College, which is where the term artificial intelligence was officially coined.
And that optimism? It wasn't just hot air. It was fueled by some absolutely incredible early wins. I mean, think about it. All the way back in 1952, Arthur Samuel's checkers program showed that a computer could learn and get better on its own. That was mind-blowing at the time. Then, after the big kickoff at Dartmouth in '56, we got things like the General Problem Solver, which was a very early attempt to model how humans actually think. You can just feel the momentum building, right? But you know how it goes. After that initial explosion of excitement, reality started to set in. Researchers basically ran headfirst into a wall. That dream of a thinking machine, it was proving to be way, way harder than anyone imagined. And this kicked off a period where progress stalled and funding dried up. People now call it the first AI winter. Okay, and this slide, this is just a perfect and honestly hilarious example of the problem they were facing. The story goes, researchers tried to translate the English phrase, "the spirit is willing, but the flesh is weak," into Russian and then back into English. The result? The vodka is good, but the meat is rotten. I mean, come on. It's a brilliant, funny way to show that real intelligence is so much more than just swapping words. It's all about understanding context. So why was it so tough? Well, it really boiled down to three main things. First up, raw computing power. The machines back then just weren't strong enough for the job. Second, they were starved for data. You gotta remember, AI needs tons and tons of information to learn from, and back then, it just wasn't available. And finally, the big one we just saw, context. That common sense knowledge that you and I use every single second without even thinking about it, machines had absolutely none of it. So what happened? Well, researchers had to make a big pivot, a really smart one actually. This huge, grand goal of building a general, human-like mind, they had to put that on the back burner. Instead, they came up with this new, way more practical idea. Hey, if you can't build a jack of all trades, why not build a master of one? And this idea, it led to the rise of what we call expert systems. And these were a total game changer. Instead of trying to know everything, these systems were designed to know one thing, but they knew it perfectly. You had Mycin, which could diagnose blood infections, sometimes even better than junior doctors. Dendrel was a wizard at identifying chemical structures, and XCon, it mastered the ridiculously complex job of configuring computer systems for customers. This was the moment AI proved it could have real, serious commercial value. Okay, so that's a quick trip through history. Now, let's fast forward to today. The field has evolved so much, and to really get a handle on the modern world of AI, we gotta nail down a few key terms. This is the foundation for everything else, so listen up. This diagram is one of the most important things to get, so let's break it down. The easiest way to think about it is like one of those Russian nesting dolls. On the very outside, you have artificial intelligence, or AI. That's the big umbrella, the whole field of trying to make machines smart. Okay, open that doll. Inside it, you find machine learning, or ML. This is a specific way of doing AI, where you let the machine learn directly from data instead of programming it with a bunch of rules. And then open that doll one more time, and you get deep learning. This uses complex brain-like structures called neural networks to find really subtle patterns in massive amounts of data. So just remember, all deep learning is a type of machine learning, and all machine learning is a type of AI. Right. Another super important thing to get is that when people say they're building AI, they could mean one of four very different things. It all comes down to two questions. Are you trying to copy humans, or are you aiming for perfect logical rationality? And are you focused on thinking or just on acting? So you could try to build a machine that literally thinks like a person, or one that just acts like a person. That's what the famous Turing test is all about. On the other hand, you could forget about humans completely and just focus on pure, cold logic, thinking rationally. Or maybe the goal is to build something that just acts rationally out in the messy, real world to achieve its goals. All four are valid, but they lead to very different kinds of AI. Of course, AI isn't just a technical thing, right? It's huge in our culture. It has this massive grip on our imagination, and a lot of that comes from movies and books, which just love to explore our biggest hopes and, yeah, our biggest fears about all this. I mean, just think about a show like Westworld. It uses these incredibly lifelike androids to ask these gigantic questions, like what even is consciousness? If a machine believes it's alive, are we allowed to say it's not? Pop culture becomes this kind of sandbox for us to play with these ideas, pushing us to think about the ethics of it all long before we might have to in real life. Okay, so let's pivot from the philosophical back to the practical. How do we actually go about building these systems? Well, to understand that, you have to understand the core concept of pretty much all modern AI, the intelligent agent. So what in the world is an intelligent agent? The definition sounds kind of technical, but it's actually super simple. It's just anything that observes its world using sensors and then does something in that world using what are called effectors. It's a constant loop. Sense, think, act. That's really it. And to make this crystal clear, look no further than, well, you. You are an intelligent agent, a biological one, but an agent nonetheless. Think about it. Your sensors are your eyes, your ears, your sense of touch. Your environment is everything around you. Your effectors are your hands, your legs, your voice. And the actions you take, walking, talking, grabbing a cup of coffee, this basic idea works for humans, for robots, and even for a piece of software.
Okay, here's the key point. The thing that really decides how smart or complicated an agent has to be is the world it lives in. And believe me, not all environments are created equal.
For instance, you could have a deterministic environment, like a game of chess. Every single move has a perfectly predictable results. The opposite of that is a non-deterministic world, like, the real world, where things are uncertain and you can't predict everything. Then you've got episodic environments, where every action is a one-and-done deal. Think of a robot on an assembly line just sorting parts. Each part is a new, separate problem. The alternative is sequential, like driving a car, where everything you did a second ago has a direct impact on what you need to do next. As you can imagine, building an agent for each of these worlds requires a totally different playbook. And that brings us full circle. We've figured out the engineering. We have a clear, logical framework for building rational agents, systems that can perceive, reason, and act to get things done. We have the technical roadmap. But it leaves us staring right at the biggest, most profound question of all, the same one those pioneers were dreaming about back in the 50s. At what point does a perfectly rational agent cross that invisible line and become truly conscious? Now that is something to chew on.